Hello, good evening everybody. My name's Irfan Chowdhury. I'm the Vice President of Strategy and Partnership at the Saudi Space Commission. Before I start, can I say a very warm welcome to all of you here this evening, especially the children. And I note that this is also being live broadcast to colleagues in Jeddah and Dhahran as well. So a warm welcome this evening on a Thursday night. Over the next 30-40 minutes, I'm going to talk a little bit about my space journey, how I got interested into space, what was the attraction, and also what was the particular interest from my perspective. And I am available after this presentation if you want to ask questions on a personal one-to-one basis. So very happy to take those questions as well. So as I said, my name's Irfan. I'm the Vice President of Strategy and Partnership at the Saudi Space Commission. That involves a number of important key elements within the role, and I want to say a little bit more about that. But I also want to share a bit more detail about the International Space Station, our 2 Saudi astronauts that are on board the space station, and some of the activities that they will be undertaking. So a little bit about me. My space journey properly started back in 2018. You can probably tell from my accent, I'm British. My background is UK. My parents were originally from Pakistan. But my father came to the United Kingdom in the 1960s. I was born and studied in the UK. My background, from an academic perspective, is I'm an accountant. I'm an accountant, but I've ended up in the space sector. So you might wonder how that is. And it's worth noting that the space sector, the space community, doesn't just have scientists and engineers, but it has accountants, it has HR people, it has business strategy people, it has finance people. So it's important to remember that. So my role started back in 2018 when I joined the UK Space Agency, and I had 2 key roles there. One was international policy, and the other was the international director. What does that mean? Space is multinational. There are no boundaries in space, there are no borders. So every country is working, collaborating, or in partnership in terms of the development of space and the operations that we undertake. So for me, the role at the UK Space Agency was about identifying, building and developing partnerships with other spacefaring nations, and particularly where there were opportunities to collaborate and partner in the areas of science and technology and of those key areas that we require for space operations. But also it was about space diplomacy. So which countries do we see as strategic partners and alliances? My next role was at the Department for Business, Energy and Industrial Strategy, which was the kind of parent department for the UK Space Agency. And again, here it was about international strategy and also strategy and regulation. It's a bit like driving a car. If you don't have rules or regulations or licenses, it'll be very dangerous. So in fact, the whole regulatory environment about how you operate in space, how you manage the engagement, where you launch from, what the safe environment in which to do that is absolutely crucial. So regulation was also about managing the authorities, the control, and the way in which we operate in space. And then my final journey in 2022, December, I was privileged and honored to join the Saudi Space Commission as their Vice President for Strategy and Partnership. I'll say a little bit about that journey. Back in 2021, I attended what was known as the International Astronautical Congress, a big space event that takes place every year. That year, it took place in Dubai, and at that time, I was working for the UK Space Agency, and I was fortunate enough to meet His Excellency Dr. Al-Tamimi, the CEO of the Saudi Space Commission, and also members of the team that were visiting and supporting that delegation. For me, it should also be worth highlighting that at that time, the UK had published its own national space strategy, which talked about our priorities from launch capabilities to astronauts to deep space communication to space exploration, all of those aspects. And at the time, the Kingdom of Saudi Arabia was developing its own national space strategy, particularly in the context of exploration, communication, and satellite build, manufacture, and all those capabilities. So I took the opportunity to meet with His Excellency and the team. We also talked a little bit about the strategy. I shared with the Saudi Space Commission the experiences that the UK had undertaken in building and developing its own national space strategy, and crucially the mistakes we made. And one of those was about ensuring that we had the necessary funding, the approvals. And I should just add, if I turn off space today, now, stop everything that we're operating on in space, you won't be able to use your phones, you won't be able to use your cash points, your ATMs, space, the weather forecasting will all be gone. So you need to understand that space plays a crucial role in all of our lives. So in that respect, it was refreshing to see the Saudi Space Commission and the Saudi government working through developing its own national space strategy. And within that, I will talk a little bit about the programs that we're looking to, we have envisaged, but also in terms of the national space strategy and how it aligns with the Saudi Vision 2030. So for me, I have over 30 years of experience in UK government. I started off as an accountant, as I say, but principally it's in the areas of defence, security, cyber, and then space. So my experience is built on all of those areas and those activities that I've worked in within UK government. But I've also worked in operations, in projects, in business development, and then in developing policy and strategy. But at the bottom there, you can see some of the organisations, the Ministry of Defence in the UK and the space-enabled technology that they operate under. The Royal Air Force and the Royal Navy, again, space capabilities that they require to operate. And then from the business perspective, the Department for International Trade, UK Space Agency, and BEIS. But you'll see the other one there, the logo there, is the Saudi Arabian National Guard. So in 2001, I was fortunate enough to come with the UK Armed Forces, the UK Army, British Army, Royal Signals, to work alongside the Saudi Arabian National Guard in developing their own satellite program. So in 2001, 2003, I was in the Kingdom, working alongside colleagues from the National Guard and from the British Army in support of that capability. And I should add, at that time, I was based at the Faisalea building, and Kingdom Tower was the only other high-rise building in Riyadh. So you can imagine when I came back to Saudi Arabia in Riyadh in 2022 to see the number of buildings and sky-rise facilities across the country, and particularly in Riyadh. So that gives you a little bit of background behind myself and my experiences. This is a great picture about what we mean by international relations. The top left picture you see there is the chairman and the CEO of the Saudi Space Commission, His Excellency Minister Al-Swaha and His Excellency CEO Dr. Al-Tamimi. But with them is the chap called Michael Sofrodini, who is the Chief Executive Officer, of Axiom. Some of you may or may not know who Axiom Space is, but they are the company that we have worked with to get our 2 astronauts to the International Space Station. So Axiom Space, a private company working alongside NASA and other organizations and with other governments and other organizations, are helping support the space infrastructure by transporting astronauts from the Earth's surface to the International Space Station. So that was a visit back in May 2022, when His Excellency the Minister and the CEO visited the United States. And again, it talks about that level of international collaboration and cooperation that we have identified. So the US are an important partner for the Kingdom of Saudi Arabia as we look to build and develop our own space program and our own space infrastructure. The top right picture is at the International Astronautical Congress last year in Paris. I talked about the one where I first met the Saudi Space Commission back in 2021 in ISD Dubai. This was the year later, hosted in Paris. You'll see there Dr. Al-Tamimi, but sat next to him is Her Excellency Sarah Al-Amiri, who's the chair of the UAE Space Agency. And close by, you will see representatives from the Australian Space Agency, German Space Agency, NASA, JAXA, and the United Nations. So it is a truly multinational community that we find ourselves in terms of the space sector. And again, it's worth noting that that level of collaboration and cooperation that exists. I talked about my experiences in defense, in security and cyber, But the real joint community that we see, an international relations aspect within space, is very, very impressive. And then the last one, the picture at the bottom, is my first visit as the Vice President of Space and Strategy and Partnerships in the Saudi Space Commission. Alongside His Excellency, our first international visit was to India, and specifically our colleagues at the Indian Space Research Organization. And we got to see their facilities where they conceive, build, design, and develop satellites and infrastructure. A very impressive regime that they've built and developed in India in terms of the linkages between the academic institutions, in other words, their universities, but also in partnership with the government and with industry. So you see that partnership between the Indian government, the Indian Space Research Organization, industry and academia working alongside each other. And that's been really quite impressive. And the way that India have done it is potentially a model that we would want to see replicated here in the Saudi Space Commission and in the Saudi space sector that we're looking to build and develop. So what do I mean about when I talk about international relations and how important it is? It's about building and developing those partnerships and those relationships. Which are the countries, which are the capabilities, which are the areas that we want to cooperate and collaborate on? And that's been a real important part of that. The other part is building and developing those international agreements. And I'll say a little bit more later on in my presentation about those international agreements and what that means for us. But there are also many organizations and committees that are important within the space community. Particular one I would want to highlight is the UN, the United Nations Office of Outer Space Affairs, UNOSA, which talks about they have legal aspects, they have science and technical aspects, and various committees that bring all those United Nations members together to effectively provide what we refer to as the rules of the road or the rules of space, providing the guidance and the illustration for how that we should be effectively operating in the space environment. And then, crucially for me, and as part of the National Space Strategy, is to build and develop that ecosystem within the Kingdom of Saudi Arabia. We have that. We have some very impressive companies that are tech startups that are developing capability. But what we need to build and develop is that ecosystem, that culture, the environment, the whole supply chain, bringing in academics, bringing in research organizations, bringing in private companies from across the globe to come and invest and grow their business from the kingdom. And again, that's been a really important part of the work that I do and my fellow vice presidents and His Excellency. And we're committed to that with the support of not just His Excellency Minister Al-Swaha, but also the Supreme Space Council, which is chaired by the Crown Prince, the Prime Minister. And it's important to note that that level of support and commitment that we get ensures the profile and the recognition that space has as part of the important ecosystem within the kingdom. So I want to say a little bit now about the International Space Station. The International Space Station, our 2 astronauts are there. They will be there for about 8 or 9 days. So the first thing to note, it is the home for our astronauts. Currently, there are 11 astronauts housed on board the International Space Station. And I'll show a little bit more about that detail as well. But also, during that time, there will be also work that's being undertaken in terms of scientific experiments. So it's a laboratory as well. So it's a home, a laboratory, undertaking those scientific experiments. For our 2 astronauts and the 4 that actually flew up on the Axiom AX2 mission, there are over 20 scientific experiments that they will be undertaking while they're up at the International Space Station. And in respect of that, 14 of those have been designed, developed, conceived by Saudi academics in some of our institutions within the Kingdom of Saudi Arabia. And it's also worth noting that they are broadcasting some of that work and some of those live experiments back to schools in the kingdom and working on those with schools children live. And those program of events should be available on the various websites. But they will also be conducting a number of scientific and research experiments across a whole range of issues. And again, one of those astronauts, our Emirati astronaut, will be there for about 6 or 7 months. So he'll be having a long stay program there. Worth adding a few facts: 250 miles above the Earth's surface. But the International Space Station itself is a multinational institution. It's an organization that brought NASA, the Russian Space Agency Roscosmos, JAXA, the Japanese Space Agency, the Canadians, CSA, the Canadian Space Agency, and the European Space Agency. So given all the things that are happening on Earth at the moment, and when the International Space Station was designed or conceived, built and developed, to see that cooperation between NASA and Roscosmos at that time and that stage was incredible. It's not something you can get on Earth, but they were able to do that in space. And then bringing in partners from the European Space Agency, and at that time the UK building effectively a partnership within the European Space Agency, but seeing JAXA and Canada as well. And again, they see the importance of that international collaboration. So again, the other aspects of that, the ownership and the occupation is determined by intergovernmental treaties and agreements. So that's the bit that I get involved in, to making sure that we've got the arrangements in place that allow cooperation with our US, Russian, Japanese, European and Canadian partners and colleagues. So here's one of the pictures I showed you. The top left-hand corner, the AX-2 mission, there are now 11 astronauts aboard the International Space Station. Relatively cramped, relatively close hold, but it gives you an idea. So that was a picture that's taken 2 days ago when our 2 astronauts arrived on board the International Station. There are Russian, there are US, Saudi and Emirati astronauts on board that space station as we speak. And then the picture on the right, we need to colour it in green for Saudi Arabia, but this gives you an indication of all the countries that have visited the International Space Station since it was open for business. And you'll see the geography and the layout and the level of engagement that has existed across the world in the context of space travel, and particularly in terms of being up in the International Space Station. So that gives you a hint in terms of the geography and the kind of profile in terms of those astronauts. But let's go into a bit more detail. So this is the original design plan back in 1998. The solar panels, there's work done by Canada, Japan, the European Space Agency. They all have parts to play in the construction, development and the establishment of the facility itself. And you can see some of the size and the scale of the activity that's undertaken. But the real work, the living accommodation in all of that, is this area here, the white area in the middle. That's the accommodation area. The rest of it is effectively life support for those astronauts and for the safety of the International Space Station. Because the important thing is not just to get our astronauts up there, but to bring them back safely to Earth as well. So that's crucial. And again, you can see the collaboration that's existed with the flags of the space-faring nations, but also the companies, the commercial companies that have been involved in partnership with space agencies and with those national governments. The next slide, this is my favorite slide actually. So probably needs to be, no, it has been updated. It's got Kingdom of Saudi Arabia. It's available on, I think it's Wikipedia. But I just wanted to give this to you as a flavor of, one, on the left-hand side, the countries and the flags of those countries that have visited the International Space Station. Some of them, many of them, are in the ones, Israel, Denmark. Who knew Kazakhstan had an astronaut? You know, if I asked you to name 5 space agencies across the world, you may well struggle after NASA. I know the UKSA, but after that, very limited, but there we go. So South Africa, my colleague, my fellow VP, Dr. Val Mansami, who looks after the operational organizational design of the Saudi Space Commission, was formerly the CEO of the SANSA, the South African National Space Agency. So many of these countries, they look at an astronaut as being a symbol. And it is a clear symbol to their community, to their generations, the next generation. We now have the first Saudi woman at the International Space Station. What impact is that going to have on the next generation? I remember when I was in the UK, we've got 2 astronauts, Dr. Helen Sharman and Tim Peake. And the most recent one was Tim Peake. But when he came back to the UK from his period of stay at the International Space Station, He spent literally 1 year just visiting and traveling around schools and academic institutions talking about his experience and his engagement, because that's designed to encourage those students to think about science, technology, engineering, maths, all those other areas that they should be interested in and developing, and hopefully going into the space sector or the space organization and building and developing. So it's as important about the next generation as it is about what we're trying to achieve now. But it's also designed to help improve and increase our economic standing, because there is commercial return that comes from this as well. There are some who go up to the international station simply because they are tourists, and South Africa, there was a tourist, but many of them are there conducting work, scientific experiments on behalf of the behalf of their national space agency. So in total, there have been just under 400 missions or flights up to the International Space Station. There have been 245 astronauts. Of that, 35 have been women. And I think, 2 of those astronauts have flown 5 times to the International Space Station. So you just put that into context. And you'll see again by the numbers, clearly the US and the Russia are at the top there in terms of their number of individuals and the flights. That's been an important aspect of it. And then as we go down, you'll see the number of women and the number of double, triple, quadruple and quintuple flights that those people have taken, those astronauts have taken. And I think that's really important to see. So again, 245 astronauts on the International Space Station since it was built and established in space. And that's going to be really important for us. Interesting enough, the International Space Station is due to go out of service in the next 10 or 15 years, although there's a plan for an extension, certainly up to about 2030. But it'd be interesting to see what happens after that. What is proposed after that is the US are looking at a space station that will orbit the moon. China are looking at that from their perspective as well. And it's worth seeing that we're seeing part of that divide, the geopolitics, the US-China narrative, all of that playing out. But it's important, that's why it comes back to being more important that we have rules of engagement and operation in space. That's why we have the United Nations, that's why we have the elements of the Sustainable Development Goals, that's why our operations are quite important. So the next bit I want to talk to you about is the bit that I was involved in when I was in the UK as the International Director of the UK Space Agency, but the next element, the next big journey for the space community, and that's Artemis. It's a NASA-led lunar exploration program, and I want to give the next 2 slides to give you a little bit of an overview about what that means. So the program was started back in 2017, and the plan is for that first trip back to the lunar surface in 2026. Worth adding that Artemis, in Greek mythology, is the twin sister of Apollo. And those of you who are old enough can remember the Apollo missions, particularly the moon landing. So it's apt. The reason why that's apt is because in 2026, we expect to see the first woman and the next man walk on the lunar surface. And that's, again, another powerful message. Unfortunately, I was too young to remember the moon landing, but I have an elder brother who remembers it vividly. But for this next generation, in our lifetime, we are going to see another man and a woman walk on the lunar surface, and potentially in our lifetime, see a man and a woman walk on the Martian surface as well, because that's part of the plan. And so the Artemis program itself brings in what's known as the Artemis Accords, which is effectively an international agreement or rules of the road for effectively operating on the lunar surface and then on the Martian surface as well. So NASA is leading that program. There are certain countries that haven't been engaged. There are certain countries that have very much willingly engaged. And it's worth adding that the Kingdom of Saudi Arabia, the Saudi Space Commission, is now a formal signatory to the Artemis Accords. And it will clearly demonstrate our ability not just to go back to the lunar surface, but then also onto Mars. And the ability and the technical aspects of going onto Mars require us to build habitation and sustainable development whilst we're in the on the lunar surface or in the lunar orbit. So in other words, we don't keep relying on hauling equipment, water, food, whatever it may be, from the Earth to the Moon, then onto Mars, but using the lunar surface and the Moon as a habitable environment. So in fact, perhaps in our lifetime, we will see those habitable environments on the lunar surface. So again, it's worth adding, it was originally supposed to be a bilateral agreement. It's expanded. There are now 31 countries that are members or signatories to the Artemis Accords. And it's grounded on the United Nations Outer Space Treaty that was established back in 1967. So that document back in 1967 still holds true. The Artemis Accords themselves are effectively designed to operationalize that, to bring that into effect. You just have to look at what technology was like in 1967 compared to 2023. Gives you an idea of how challenging an environment and actually how robust the Outer Space Treaty of 1967 has been. But it's designed to give us guidelines and best practice. And again, working collaboration and partnership with those strategic partners that have signed the Artemis Accords. Looking at civil exploration, the lunar surface, but also outer space. One of the programs I was involved in back in the UK in cooperation with some of our academic institutions was looking at developing deep space communications and effectively, as someone quite rightly put it, Wi-Fi for the moon. So looking at that capability and that technology. As I say, I'm a humble accountant. What do I know about that level of technology? But it's impressive and it's achievable, certainly within our lifetimes as well. So those things that we're looking at in terms of the exploration, the ambition, the excitement, the scale of which we're looking to develop is impressive. So this is my last photograph. So this was the time back in July last year, July 22, when the Saudi Space Commission signed the Artemis Accords. Top left corner, you've got the ambassador to the Kingdom of Saudi Arabia from the US. Top right, Bill Nelson, Senator Bill Nelson as he was, who is currently the NASA administrator. And then you have on the bottom right, Her Royal Highness Princess Rima, who is the Saudi ambassador to Washington. Very engaged on that. And then you've got a colleague here, I think it's from our colleague, from the Oceans and International Environment Scientific Affairs, NOAA, as we lovingly know it. But in the bottom left, His Excellency Minister Al Swaha and His Excellency Dr. Al Tamimi, the CEO of the Saudi Space Commission. So this is just one example of our level of growth, international partnership, but also collaboration. We need to be determining which partners we want to align with, where are the capabilities that we can work and support, but crucially, where is there that cooperation? But all of that, in my view, and in the view of the National Space Strategy, should be determining that benefits back to the Kingdom of Saudi Arabia and our economic regeneration as well, and building and diversifying the economic structures. So the developments of the technology and the capability that we have identified through our various space programs is designed to do that. And our astronaut program, the 2 astronauts that we have up in space, coming back next week to the Earth's surface, back in the Kingdom of Saudi Arabia. I'll hope you get the opportunity to meet those 2 fine astronauts, but also hear and share some of their experiences. But that said, it's important to highlight that that's just one part of the ambition that the Saudi Space Commission has for the space sector. It's satellite building, satellite designing, satellite manufacturing, launch capability. We're talking about building spaceports. We're talking about space tourism. We're talking about space stations. We're talking about more astronauts. As a signatory to the Artemis Accords, what does that mean for our ambition to put an astronaut on the lunar surface or onward to Mars? So the scale, the level of ambition that we're talking about and we're looking at is limitless in that respect. But what it needs is the intellectual firepower for the next generation to build and develop that. I will have well retired by the time we look at the Martian habitat and that program. But it's important to remember that this next generation, we need to inspire and we need to build that interest and ensure that within the community there is an absolute ambition to succeed. And again, collaboration and partnership is the fundamental cornerstone of that. I think that is my last slide. It is. And can I just say, on behalf of the Saudi Space Commission, first of all, thank you for joining us this evening. I hope you get the opportunity to see our 2 astronauts in operation on the International Space Stations, particularly in the context of their scientific experiments. And certainly when they get back to the Kingdom of Saudi Arabia, there will be plenty of opportunities for you to meet them, and I hope you get the opportunity as well. So can I just say thank you very much. Good evening.
An awesome experience.
السلام عليكم ورحمة الله وبركاته. اللهم لك الحمد الشكر، الحمد لله على فرصة، الحمد لله على اللحظة التاريخية اللي نعيشها. مو بس أنا أعيشها، إحنا وأنتو سوية. استمتعنا صراحة بالإطلاق، وأنا متأكد أنكم أنتو استمتعتوا بالمشاهدة. شكرا لكل من دعمنا، شكرا كل من وقف معنا وساعدنا، شكرا لمن وصلنا لهذه المرحلة، شكرا لسمو سيدي خادم الحرمين الشريفين الملك سلمان بن عبد العزيز، شكرا لولي عهده الأمير محمد بن سلمان على هذا الدعم والتمكين والثقة فينا كشباب طموحين برغبة بلهفة بأن نحقق المستحيل بإذن الله مع دعمكم وتوفيقكم. أهلي أنا في الفضاء، الحلم تحقق، اللهم لك الحمد الشكر. وقريبا إن شاء الله في المستقبل القريب الكثير سوف ينضم لنا إن شاء الله، ونراكم قريبا من محطة الفضاء الدولية.
السلام عليكم من الفضاء. والله شرف مرة كبير أن نكون نحن في هذه الرحلة التاريخية. زي ما تشوفونا نطفو يعني ونحاول نثبت نفسنا، لكن فعلا أحب أبدأ الشكر بقيادتنا وصاحب الرؤية ولي عهدنا محمد بن سلمان على دعمه لهذه المهمة. شكرا للهيئة السعودية للفضاء، شكرا أكسيوم، شكرا سبيس اكس، شكرا ناسا، وكالات الفضاء اليابانية والأوروبية كلهم على تدريبهم لنا. طبعا شكرا لستي ولعائلتي الجميلة وأصحابي ورواد الفضاء السعوديين علي الغامدي ومريم فردوس على دعمهم في هذه الرحلة. لأبناء الوطن الغالي، نحن الآن في عصر التمكين والازدهار بفضل الله ثم قيادتنا، الحمد لله. نحن الآن وصلنا عنان السماء، فكل اللي نحتاج نسويه إنه نحلم بإذن الله ونشتغل على أحلامنا، وبإذن الله رح نوصل.
استقبل رواد الفضاء السعودي موعد الانطلاق من تلقي رائدي
السعوديين
ريانا بورناوي الكورني
ستسجل تاريخا
بمداد من ذهب
ورفع مستوى الاهتمام بالفضاء لدى الأجيال الناشئة.
Dragging copies. Go for launch.
3, 2, 1. Engines full power.
تشوف النجوم حدد أماكنها، زورها، سميها، سمي عليها، خلي الفضاء شغفك، ارتبط فيه لأنه جزء منك. صوم إذا شفت قمر، شتي مع دخلة نجم. هل أنت وحدك؟ لا، خلفك تاريخ. حفظ اسمك، ارفع راسك، شق طريقك، غادر محيطك، ادرس، ابحث، ابتكر. الهم جيل يدرس، يبحث، يبتكر، يقود البشرية. تفكر في الكون، في شمس، في قمر يسبحون، في فلك. تفكر في المستقبل، في اقتصاد جديد، في دول تسابق دول. استقل بأبحاثك، بمعلوماتك. ادرس علوم الخلية، ابتكر في الاستمطار، ابحث في الجاذبية الصغرى، لف حول المدار. ارفع راسك، تعلق بالنجوم، اطلق طموحك، خله يحوم.
دائما كنت أنا أحب الاستكشاف وأحب إني أنا أتعلم. هذا الشيء اللي أصلا وداني لمجال الأبحاث واشتغلت فيه سنوات عديدة يعني. فدحين أحس نروح لعنان السماء يعني. أول ما جاني اتصال من الهيئة السعودية للفضاء إنه يا ريانا أنت انقبلتي في برنامج رواد الفضاء، كانت هذه أجمل لحظة. تكمن يمكن صعوبة التدريب نفسها، فإنه جدا مكثف. كل يوم بالنسبة لنا مرحلة تعليمية جديدة، كل واحد فينا جاي من خلفية مختلفة، لكن يجمعنا حب الفضاء والشغف. إحساسي بالفخر بهذه المهمة أكبر شعور أنا أشعر فيه. أهم محاور رؤية 2030 دعم المملكة العربية السعودية للمرأة من أهداف الباحثين والعلماء والمطورين اللي على الأرض بيجربوا تجاربهم هذه في الفضاء. دوري الآن هو أني أمثل المملكة في هذه المهمة العلمية على متن رحلة AX2، وتعد هذه البعثات الفضائية هي أحدى ثمار هذه الرؤية، ويوصل طموحنا لعنان السماء.
أحب المجهول، أحب المغامرة، أحب الاستكشاف. استمتعت بالطيران وعشقت الطيران، والآن انتظر لي أستمتع بالطيران بطريقة مختلفة. أحد أهم اللحظات في حياتي اللي هي مصارحتي لوالدي بأني انضميت لبرنامج رواد الفضاء، كانت لحظة مؤثرة جدا. قيادتك للطائرة على سرعة تتجاوز 1000 كيلومتر في الساعة وهي سرعة الصوت، فاتخاذ القرار فيها يجب أن يحدث في أجزاء من الثانية. أن تصبح رائد فضاء هذا هدف صعب جدا، ولكن ليس مستحيل. ولد أختي الصغير أرسل لي صورة فيها قمر ومريخ وصاروخ، وحاطني أنا على القمر، راسم صورة صغيرة لي على القمر، وقال لي إذا أنت وصلت القمر أنا بوصل المريخ إن شاء الله. فأعتقد من الجميل جدا أن تشاهد مثل هذه الإلهام يوصل للأجيال وهم في عمر صغير. لن يكون لبرنامج رواد الفضاء السعوديين وجود لولا رؤية 2030. اختياري من ضمن برنامج رواد الفضاء السعوديين يعتبر أكبر إنجاز لي في حياتي. سأمثل وطني المملكة العربية السعودية في هذه الرحلة العلمية، وهي مسؤولية كبيرة جدا. نحمل راية كبيرة.
An awesome experience.
السلام عليكم ورحمة الله وبركاته. اللهم لك الحمد الشكر، الحمد لله على فرصة، الحمد لله على اللحظة التاريخية اللي نعيشها. مو بس أنا أعيشها، إحنا وأنتو سوية. استمتعنا صراحة بالإطلاق، وأنا متأكد أنكم أنتو استمتعتوا بالمشاهدة. شكرا لكل من دعمنا، شكرا كل من وقف معنا وساعدنا، شكرا لمن وصلنا لهذه المرحلة، شكرا لسمو سيدي خادم الحرمين الشريفين الملك سلمان بن عبد العزيز، شكرا لولي عهده الأمير محمد بن سلمان على هذا الدعم والتمكين والثقة فينا كشباب طموحين برغبة بلهفة بأن نحقق المستحيل بإذن الله مع دعمكم وتوفيقكم. أهلي على في الفضاء، الحلم تحقق، اللهم لك الحمد الشكر. وقريبا إن شاء الله في المستقبل القريب الكثير سوف ينضم لنا إن شاء الله، ونراكم قريبا من محطة الفضاء الدولية.
السلام عليكم من الفضاء. والله شرف مرة كبير أن نكون نحن في هذه الرحلة التاريخية. زي ما تشوفونا نطفو يعني ونحاول نثبت نفسنا، لكن فعلا أحب أبدأ الشكر بقيادتنا وصاحب الرؤية ولي عهدنا محمد بن سلمان على دعمه لهذه المهمة. شكرا للهيئة السعودية للفضاء، شكرا أكسيوم، شكرا سبيس اكس، شكرا ناسا، وكالات الفضاء اليابانية والأوروبية كلهم على تدريبهم لنا. طبعا شكرا لستي ولعائلتي الجميلة وأصحابي ورواد الفضاء السعوديين علي الغامدي ومريم فردوس على دعمهم في هذه الرحلة. لأبناء الوطن الغالي، نحن الآن في عصر التمكين والازدهار بفضل الله ثم قيادتنا، الحمد لله نحن الآن وصلنا عنان السماء. فكل اللي نحتاج نسويه إنه نحلم بإذن الله ونشتغل على أحلامنا، وبإذن الله رح نوصل.
استقبل رواد الفضاء السعودي موعدا لانطلاق الانطلاق رائدي
السعوديين ريانا برناوي الكورنيك
ستسجل تاريخا
بمداد من ذهب
ورفع مستوى الاهتمام بالفضاء لدى الأجيال الناشئة.
Dragging, copy. Go for launch.
3, 2, 1. Engines full power.
شوف النجوم، حدد أماكنها، زورها، سميها، سمي عليها، خلي الفضاء شغفك، ارتبط فيه لأنه جزء منك. صوم إذا شفت قمر، شتي مع دخلة نجم. هل أنت وحدك؟ لا، خلفك تاريخ. حفظ اسمك، ارفع راسك، شق طريقك، غادر محيطك، ادرس، ابحث، ابتكر. الهم جيل يدرس، يبحث، يبتكر، يقود البشرية. تفكر في الكون، في شمس، في قمر يسبحون، في فلك. تفكر في المستقبل، في اقتصاد جديد، في دول تسابق دول. استقل بأبحاثك، بمعلوماتك، ادرس علوم الخلية، ابتكر في الاستمطار، ابحث في الجاذبية الصغرى، لف حول المدار، ارفع راسك، تعلق بالنجوم، اطلق طموحك، خله يحوم.
دائما كنت أنا أحب الاستكشاف وأحب إني أنا أتعلم. هذا الشيء اللي أصلا وداني لمجال الأبحاث واشتغلت فيه سنوات عديدة يعني. فدحين أحس نروح لعنان السماء يعني. أول ما جاني اتصال من الهيئة السعودية للفضاء إنه يا ريانا أنت انقبلتي في برنامج رواد الفضاء، كانت هذه أجمل لحظة. تكمن يمكن صعوبة التدريب نفسها، فإنه جدا مكثف. كل يوم بالنسبة لنا مرحلة تعليمية جديدة، كل واحد فينا جاي من خلفية مختلفة، لكن يجمعنا حب الفضاء والشغف. إحساسي بالفخر بهذه المهمة أكبر شعور أنا أشعر فيه. أهم محاور رؤية 2030 دعم المملكة العربية السعودية للمرأة من أهداف الباحثين والعلماء والمطورين اللي على الأرض يجربوا تجاربهم هذه في الفضاء. دوري الآن هو أني أمثل المملكة في هذه المهمة العلمية على متن رحلة AX2، وتعد هذه البعثات الفضائية هي أحدى ثمار هذه الرؤية، ويوصل طموحنا لعنان السماء.
المجهول، أحب المغامرة، أحب الاستكشاف. استمتعت بالطيران وعشقت الطيران، والآن انتظر لي أستمتع بالطيران بطريقة مختلفة. أحد أهم اللحظات في حياتي اللي هي مصارحتي لوالدي بأني انضميت لبرنامج رواد الفضاء، كانت لحظة مؤثرة جدا. قيادتك الطائرة على سرعة تتجاوز 1000 كيلومتر في الساعة وهي سرعة الصوت، فاتخاذ القرار فيها يجب أن يحدث في أجزاء من الثانية. أن تصبح رائد فضاء هذا هدف صعب جدا، ولكن ليس مستحيل. ولد أختي الصغير أرسل لي صورة فيها قمر ومريخ وصاروخ، وحاطني أنا على القمر، راسم صورة صغيرة لي على القمر، وقال لي إذا أنت وصلت القمر أنا بوصل المريخ إن شاء الله. فأعتقد من الجميل جدا أن تشاهد مثل هذه الإلهام يوصل للأجيال وهم في عمر صغير. لن يكون لبرنامج رواد الفضاء السعوديين وجود لولا رؤية 2030. اختياري من ضمن برنامج رواد الفضاء السعوديين يعتبر أكبر إنجاز لي في حياتي. سأمثل وطني المملكة العربية السعودية في هذه الرحلة العلمية، وهي مسؤولية كبيرة جدا، نحمل راية كبيرة.
An awesome experience.
السلام عليكم ورحمة الله وبركاته. اللهم لك الحمد الشكر، الحمد لله على الفرصة، الحمد لله على اللحظة التاريخية اللي نعيشها. مو بس أنا أعيشها، إحنا وأنتو سوية. استمتعنا صراحة بالإطلاق، وأنا متأكد أنكم أنتو استمتعتوا بالمشاهدة. شكرا لكل من دعمنا، شكرا كل من وقف معنا وساعدنا، شكرا لمن وصلنا لهذه المرحلة، شكرا لسمو سيدي خادم الحرمين الشريفين الملك سلمان بن عبد العزيز، شكرا لولي عهده الأمير محمد بن سلمان على هذا الدعم والتمكين والثقة فينا كشباب طموحين برغبة بلهفة بأن نحقق المستحيل بإذن الله مع دعمكم وتوفيقكم. أهلي أنا في الفضاء، الحلم تحقق، اللهم لك الحمد الشكر، وقريبا إن شاء الله في المستقبل القريب الكثير سوف ينضم لنا إن شاء الله، ونراكم قريبا من محطة الفضاء الدولية.
السلام عليكم من الفضاء. والله شرف مرة كبير أن نكون نحن في هذه الرحلة التاريخية. زي ما تشوفونا نطفو يعني ونحاول نثبت نفسنا، لكن فعلا أحب أبدأ الشكر بقيادتنا وصاحب الرؤية ولي عهدنا محمد بن سلمان على دعمه لهذه المهمة. شكرا للهيئة السعودية للفضاء، شكرا أكسيوم، شكرا سبيسكس، شكرا ناسا، وكالات الفضاء اليابانية والأوروبية كلهم على تدريبهم لنا. طبعا شكرا لستي ولعائلتي الجميلة وأصحابي ورواد الفضاء السعوديين علي الغامدي ومريم فردوس على دعمهم في هذه الرحلة. لأبناء الوطن الغالي، نحن الآن في عصر التمكين والازدهار بفضل الله ثم قيادتنا، الحمد لله نحن الآن وصلنا عنان السماء. فكل اللي نحتاج نسويه إنه نحلم بإذن الله ونشتغل على أحلامنا، وبإذن الله رح نوصل.
استقبل رواد الفضاء السعودي موعدا لانطلاق الانطلاق رائدي
السعودي ريانا بورناوي الكورني ستسجل تاريخا
بمداد من ذهب
ورفع مستوى الاهتمام بالفضاء لدى الأجيال الناشئة.
Dragging copies. Go for launch.
3,
Okay, good evening, everyone. I trust everybody's okay. I think this is a very proud moment for Saudi Arabia, and I think we're making history with the two astronauts that are up in the International Space Station. And just to give you a sense, there's a strategy for a national space program that's in the process of being approved. And it's a very ambitious program, so there's lots more to come. So this is only signaling the beginning of a new era in space in Saudi Arabia. Just by way of introduction, my name is Val Munsami. I've joined the Saudi Space Commission. I'm formerly from South Africa. I used to be the head of the South African National Space Agency, and I've worked in government for over 25 years, working in the space sector. And I'm also currently the Chancellor of the International Space University. So I'm really excited to be here, given what's in the cards for Saudi Arabia. So today I'm going to just talk through the space environment and its uses, and just give you a synopsis in terms of what the space environment looks like, given that we have two astronauts in space at the moment. So just to share with you, when you look at the history of how space evolved over the last 50 years, we started off in the sort of 1800s with space 1.0, which is primarily astronomy. So everybody kind of looked up in the night sky and wondered what this universe is all about. But there was also a nice use case for astronomy, because if you look at the stars, they have fixed positions on the night sky. So we used it for navigation, especially sailing on ships and so on. So it gives you a nice reference frame in terms of which you can navigate against. Then there was space 2.0, which was a sort of late 1950s. And this was a space race, or the Cold War, between the US and the Soviet Union. And the Soviet Union kind of jumped ahead with the launch of Sputnik, essentially. And the US had to respond. They saw this as a threat. And that's where the Cold War sort of kind of emerged in terms of proving technological supremacy between Soviet Union and the US. And that was followed by an era called Space 3.0, where there was a lot of international collaboration between many nations to build space stations. So the Russians built the Mir space station, and right now we have the International Space Station, where our two astronauts are actually residing for 8 days, essentially. And so Space 3.0 is international collaboration, but still largely driven by national space agencies like NASA, the JAXA, and the likes. We now move into what is called Space 4.0. And this was actually stimulated by the shuttle disaster Columbia, where the shuttle exploded and a few astronauts lost their lives in that. You'll remember that a few years ago. And NASA had to take a deep look as to whether it was actually implementing these programs in a more sustainable and cost-efficient way. And it decided to de-risk the sort of space program by bringing in industry to help to innovate and so on. So there's a lot of industry involved in the space sector as we speak. So this is how space evolved up until today, which is where we are at Space 4.0. So I want to start maybe just on the astronomy side and jump into the space environment, and then land up with how we use space for our daily uses. So this is a diagram of what the universe actually looks like. So just to give you a sense, when you look at light, it travels at a certain velocity. To be exact, it's around 3 times 10 to the power 8. That means it travels at 300,000 kilometers every second. 300,000 kilometers every second. That's the speed of light. Now, when you look at the sky at night, okay, the closest star we have, which we see during the day, is the sun. The sun is a star. But when you look at the sky at night, the closest star is Alpha Centauri, which is around 3 light years. Now, what does it mean? As I said, light travels at 300,000 kilometers per second. So the light you see coming out of the nearest star, which is Alpha Centauri, left that star 3 years ago. So you're seeing that star 3 years back in time. Okay? So if you go further into the universe, that means you're seeing those stars much further back in time. In fact, billions of years. Okay, so if we're standing here, and if you look back in time, we can only measure up to 13.7 billion years. And that's what we estimate the age of the universe is. That it actually started around about 13.7 billion years ago. So something happened 13.7 billion years ago. And we refer to that as the Big Bang, essentially. There was a massive explosion, and energy was given off, and we had what is called quantum fluctuations, more from the physics side. And then round about 400 million years after that point is when the first stars start to emerge. So this is how the universe was sort of created. And because of the Big Bang, the universe is expanding, but it's also accelerating at the same time. Okay? And so when you look back, you see the universe expanding and accelerating at the same time. But there's some interesting things about the universe that we should note. So if you look from the outside, can we get the video going? Okay, there was supposed to be a video that played with this, but shows you, can we see? Okay, that's not working. All right, so let me talk through the previous slide. So there was supposed to be a movie where you're coming from the edge of the universe and you're traveling, and it's supposed to give you a sense of how small Earth is compared to the entire universe. And when you look at it from that perspective, by the way, scientists only understand 5% of the universe. There's 95% of the universe that we don't understand. Okay. The other thing is, when we try to look at how the universe is constructed, we bring in new concepts that we don't quite understand to explain what we're seeing and observing. So for example, when I said the universe is expanding, if you think about a balloon, and if you're blowing up the balloon and it's expanding, that means you're putting in energy. So scientists think that there must be energy in this universe that's pushing the universe outwards. But we can't see the energy, so we call it dark energy. And then there are galaxies, billions of galaxies across the universe. And each galaxy, like the Milky Way that we live in, is hundreds of millions of stars. But the interesting thing is the galaxies stay together. And for a big, large body like the galaxy to stay together, there must be some mass. And that mass we cannot see, so we call it dark matter. And Einstein's general theory of relativity is trying to explain about the universe. And if anybody goes to university and studies physics, will learn about Einstein's theory of relativity. And it talks about reference frames that are moving very close to the speed of light and accelerating in the case of general relativity. But that theory explains a lot, like black holes, for example, which are very dense matter. So what we are trying to do, as I said, because we only understand 5% of the universe, we're trying to make sense of the universe. So we build instruments on the ground that is trying to make measurements of what we can see in the universe. And there are two types of instruments that we build on Earth. The one is radio telescopes, and the other one is optical telescopes. So radio telescopes is essentially trying to listen to the universe, whereas optical telescopes like the one on your right, this one, is trying to see into the universe. Okay. Now, just to give you a sense, everything you see and hear and feel is driven by what we call electromagnetic waves. Okay. If you go to a doctor and if you take an X-ray, the X-rays are very short wavelength but very high energy. So they can pass through your skin but not through your bone. So you can get an image of your skeletal structure because the X-rays go right through your flesh, essentially. And then you go to the other extreme where you have radio waves, which are very long wavelengths, but low energy. So they can travel very long distance. So listening to a radio channel on your car at home, that's coming through because of radio waves. So it's all electromagnetic wave radiation. So what this kind of telescope on the top is trying to do is trying to listen to the universe. The only thing that's limiting us to how well we can listen is the surface areas of your dishes. Now, you want to build these antennas or dishes as big as possible. But the problem is you run into construction or the engineering where you cannot build very big dishes. And by the way, the curvature of these dishes have to be accurate to within a few millimeters. So the bigger the dishes you have, the error for that surface increases. So what engineers do is they build many dishes and they link them up. But it's actually one instrument. It's not many dishes. It's one instrument. It's all connected by optical fiber networks, and they're all synchronized as one instrument. So why do we have so many dishes scattered about? And that talks to what we call the resolving power of the instrument. So what is the resolving power? So the dishes are scattered because of what we call baseline interferometry. So just to explain to you, if you had to look up and try to measure the distance to a star, it's very difficult. So what you tend to do or want to do is stand on one point of the Earth, look at the star, measure the distance, and then you go back. Sorry, this is the video that you missed earlier on. This is coming from outside of the universe. It's going not close to the center, but it's heading towards the Milky Way, essentially. Okay? So this is giving you a sense of how small we are. This is actually the Milky Way that's coming in view at the moment. And there's hundreds of billions of stars in the Milky Way. And if you keep going in, you come to a point where we actually are living. So you'll see the sun sort of emerging as one of the stars in all of this. Okay, that's the sun that we are used to seeing. And if you look closely, you'll see all of the planets coming to view. And the third planet from the sun is actually where we're living. Okay? So we are actually on a spaceship in the universe. And that's Earth. And this was supposed to give you a scale of how small Earth is compared to the universe. And that's why I was saying that we only... Sorry. Can we stop the video? It's going on a cycle. Okay. Yeah. So I was explaining to you how we measure distances to stars. We stand on one point of the Earth, measure the angle to the star. We stand on a different point of the Earth, and we measure the distance, the angle to the star. If we know the distance on the ground, if you form a triangle, you can actually measure or calculate the distance to the star. And that's how these dishes, because they're scattered, they can start to measure and resolve distances to various stars. And that's how we know the distances to various stars. What you're seeing here is an optical telescope. All of these instruments are being built in South Africa, where I come from. This is the Southern African Large Telescope. It's a 10-meter mirror. And this particular telescope has the ability to resolve intensity that's 25 million times more than your eye can see. So it can actually see, for example, a candle on the surface of the moon. That's how powerful this telescope is. So it's trying to look into the universe with these telescopes. So I want to just focus on our star, which is the sun, because that's where we get our heat, where it fuels life on Earth, and it drives all of the weather systems, the climate, the water cycle, all of that is driven by the sun. So in the middle of the sun, we have what is called a thermonuclear reaction. So essentially, you have hydrogen atoms, they fuse together, and they form helium atoms, and there's a lot of energy that's given off. And this energy that's given off essentially is what you see as heat and light. But there's more to that than what you see. And you can see these streams of what we call plasma coming out of the sun. Now, just to give you a sense of what plasma is, if you take ice and you melt it, it becomes a liquid. If you heat the liquid, it starts to boil and vapor comes out. If you heat the vapor, what actually happens is the electrons and the ions starts to separate because you're giving it additional energy. That's when you form a plasma. So you get solid, liquid, gas, and then plasma. Okay? So that means plasma is very high energy. So what's coming out of this is very high energy. On a quiet day, when nothing is happening on the sun, the velocity of this plasma is around 400 kilometers per second. Okay? So that's what we call the solar wind. It's constantly there, it's bombarding the earth. But every so now and then, we have these disturbances on the sun. So if you look at your picture that's kind of shown in the green circle, if you take a magnifying glass and you point it towards the sun and you put a piece of paper beneath it, what you will see is a circular disc, but you'll see those little spots. Those spots are actually called sunspots. And if you had to look through a satellite, for example, that's what it looks like on the surface of the sun. And the reason for that is there's a magnetic field in the sun that's trapping all of the plasma and making it look cooler than the rest of the sun. Okay. And those kind of activities, those sunspots, if you have to count them, they follow an 11-year cycle. So the sun gets very active, and then it calms down, it gets active again. So it's like the seasons of the sun. So what actually happens is when that sun is spewing out the plasma, and if there is a very active event happening in the sun, that plasma, which I said is normally 400 kilometers per second, is now moving around 600 to 1,000 kilometers per second. So it's accelerated. And the only thing that's protecting us on Earth is the Earth's magnetic field. If we did not have a magnetic field on Earth, you and I would not be here. There will be no life on Earth. So the Earth's magnetic field is actually protecting us from that radiation that's coming from the sun. And this is something we have to consider because there's a lot of talk about going to moon, going to Mars. And by the way, the moon nor Mars have a magnetic field. They are not shielded from radiation. So if you have astronauts living on the surface of the moon or on the surface of Mars, you have to ensure that they have added protection, that their habitat must have some sort of a magnetic shielding that can protect them from radiation. So this solar wind is actually, or the magnetic field is protecting us from that solar radiation or the solar wind. And there's a whole physics domain that's kind of attributed to how the solar wind is interacting with the Earth. So this is the magnetic field lines that you see, okay? And what's actually happening is the solar wind is coming, it's squashing the magnetic field on the night side, and it's pulling the tail like a slingshot. The magnetic field lines are not solid, they're not rigid, so they can stretch. It's pulling the tail into what we call a magnetotail. Now what happens if you pull a sling and you keep pulling it? At some point in time, it's going to snap. And that's what normally happens, is this tail snaps. And all of the energy that's on the magnetic field gets dumped into two places. One is in the center, okay, right here. Those two regions. Those are called the Van Allen radiation belts, where the radiation collects, okay? And that's where, for example, a lot of the satellites are orbiting, and that's also where the International Space Station is moving across as well. The other area you can see at the bottom and the top. And you can see all of that feeds into the polar regions, the South Pole and the North Pole. And by the way, that's what creates the aurora. That energetic particles, which gets fed into the polar caps, the atmosphere. So when these high energy particles come into the polar atmosphere, they knock into the various molecules that are sitting in that polar atmosphere. So oxygen, if these energetic particles hit the oxygen atoms, it gets excited, it moves into higher energy states, and it wants to come back down. And when it comes back down, it has to release energy. And the energy it releases is heat and light. And the light that we see is typically green. Whereas nitrogen, when it's excited and wants to come back down, the light that it emits is a pinkish color. So when you look in the South Pole or the North Pole, when there's aurora, you'll see this pink, green light, what we call the auroras, okay? And that is just showing you how the auroras actually come about. So how is this relating to space? So we have a lot of technologies that we operate in space, satellites, the International Space Station. We're trying to go to the moon, we're trying to go to Mars. So we're using space as an environment. But this radiation is a bit of a problem because it affects all of the technologies that we have. So if you look at the top right, there's a satellite that's orbiting the Earth. And I'll come back to explain how we get things to orbit around the Earth. When the satellite is orbiting around the Earth, because these charged particles are increasing in the Earth's environment, that charged particle can get into the satellites. And because it's charged particles, it can damage the electronics. And we see a lot of satellites that are actually damaged because of the radiation. The other thing that we notice is that the astronauts in the International Space Station, very often there's space walks where the astronaut actually gets outside of the space station and they go and repair any damage that's taken place or putting new instruments on the outside. But they will not be able to do any space walks if there's excessive radiation. Okay, so if there's a solar storm, there will be no space walks. The other aspect is, if you look at the ionosphere, there's currents floating, there's excessive radiation that's floating. And the moment you have currents floating in the ionosphere, if you did school physics, you might have heard, or science, learnt about Lenz's law. If you have two pieces of wire or cable, conductors, and if you put a current in one of them and you vary it, you'll induce a current in the other conductor. So if you've got a current flowing in the ionosphere and it's varying, it's going to induce currents on any electrical cabling or conductor that's on the Earth. And so that poses a problem because the electrical grids are conducting wires. And we've seen in many instances where electricity grids are blown apart because of that current in space. And that's because it saturates. So as part of the grid, we have these transformers. a step up or a step down transformer, it actually saturates those transformers and it blows them up. And we see a lot of that happening, especially in the Northern Hemisphere. And by the way, we have Aramco, which is the biggest oil company in the world. Interestingly enough, it also is affected by space weather. Because there's a current in the ionosphere, those oil pipelines, because they are metallic structures, currents will also be induced in the oil pipelines. Now, the moment a current is flowing in a metal structure, it increases oxidation, which is corrosion or rusting. So those pipelines tend to rust much quicker if there is space weather effects. If you've ever flown on a plane, most of us have flown on planes in this day and age, it's now regulated that pilots must have space weather information on board. And this was since November last year. You must have space weather information on board before you take off. And the reason for that, there's 3 reasons. One is you get excessive radiation. Now, radiation is not good for you. So, for example, when you're doing X-ray, as I said, it passes through your skin. But what happens when radiation hits your skin? Because it's high energy particles, it actually starts to damage your skin. It kills the cells in your skin, okay? Now, unfortunately, you might know of many people that suffer from cancer. They go for chemotherapy. It's actually radiation. They're actually given doses of radiation. And the way that works is because cancerous cells are fast dividing, they eat much quicker than your normal cells, okay? So they try to grab the radiation or the chemical that's in your body. Have you ever noticed that people lose their hair when they go for chemotherapy? You know why? Because your hair is also fast dividing. Your hair grows very quick. So it damages your hair as well, as much as it damages the cancerous cell. So radiation is actually not good for you. So you don't want to be flying in an aircraft if there's excessive radiation. The second thing is that these pilots, when they are flying, they're continuously communicating with the ground station. And the way they do that is they transmit a signal. That signal is bounced off the ionosphere and it comes back to the ground. But when you have excessive radiation in the ionosphere, it actually absorbs. There's no signal coming back. So the pilots cannot communicate to the ground station. So you have radio blackout. Okay. And the third effect is that the pilot is also using satellites for navigation, like GPS satellites. So that signal from the satellite does not come through the ionosphere. It gets attenuated. So this pilot cannot see where he or she is flying because the signal is attenuated. So it's actually quite dangerous to fly when there is this space weather phenomenon. So it's trying to give you a sense that space is not an easy environment. It's actually a very tricky, dangerous environment to operate. Okay. So just to give you a sense, this is the image of the sun in 2022. This is January, late January. You can see the sun is very active, and this picture here is what is called a coronagraph. Now, just to give you a sense, there are many satellites that are trying to observe what's happening on the sun. And we put satellites into what we call libration points. So, for example, there's what is called an L1 libration point. So, if you put an object between the sun and the earth, at some point in time, or in space, the earth is pulling on that object and the sun is also pulling on the object. But if those forces cancel out, there is no net force on any object sitting in that libration point. So we use that fact to put satellites out there that we can observe the sun, as an example. So what this particular satellite is doing is it's looking at the sun, but it's blocking out the center of the sun so it can see the disk around the sun, or what we call the corona. So this is called a coronagraph, okay? So you can see from this coronagraph, the sun is very active. It's spewing out plasma. There's something happening in the plasma. And unfortunately, that particular plasma came towards the Earth. And there's something interesting that happened on this day. Around about 2022, it's actually a few days later, Starlink launched 49 satellites for communications. Of the 49, 40 was destroyed. Only 9 survived. 40 of those satellites was taken out because of what came from the sun, the radiation. It hit the sun, destroyed the satellites, and actually 2 things. The radiation seeped into the satellites, destroyed the electronics, but because of this excessive radiation, there's excessive resistance. And the moment you feel resistance, if you put your hand outside of the car, you can feel the resistance. So it slows down the satellite. When a satellite slows down, it falls out of the orbit, and it starts to get into the atmosphere and it burns up. And that's essentially what happened with the 40 Starlink satellites. Okay. So you can see there's just proving how dangerous the space environment actually is. So I just want to turn attention, after demonstrating to you how dangerous the space environment is, why do we actually go to space, and what do we use space for? So we put objects into orbit. So I want you to understand and visualize what is an orbit. So here's a guy throwing a baseball. Okay, so if you throw the baseball, it follows that trajectory and it lands a certain distance. But what happens if you ask that baseball player to throw it even further, so the ball goes even further? And if you keep doing that, it goes further and further. Okay? You have to put more energy, so it follows that trajectory, but it goes further and further. If you keep doing that, if you throw that ball further and further, or that object, at some point in time, that object is falling towards the Earth, but the Earth is spherical. So as it's falling, the Earth is curving away from it. So it lands up going around the Earth continuously. That's how you put an object. When you're launching a satellite, you're throwing it into space, and using the fact that the Earth is spherical and it's curving away. So the object is falling towards the Earth but not reaching the Earth because the Earth is spherical. And by the way, the International Space Station is essentially exactly that. It's actually falling towards the Earth. So it's not zero gravity, it's microgravity. You're actually falling all the time. Okay? And you feel like you're floating, but you're actually falling. Now there's 3 different orbits that we normally talk about, actually 4 if you look at space exploration. There's the low Earth orbit, which is about 400 to 600 kilometers. And we use that for what is called remote sensing satellites. And then there's the medium Earth orbits, which is a few tens of thousands of kilometers. Your GPS satellites, navigation satellites, are put in medium Earth orbit. And then there's geostationary orbit. A geostationary orbit is used for telecommunications satellite, and I explained that just now. It's about 36,000 kilometers away. So if you are watching digital TV at home, satellite TV, that signal from the broadcaster is going to a telecommunications satellite, which is 36,000 kilometers away, and is being retransmitted back to Earth. So if you have a dish on your roof, a satellite dish, you'll notice that in your neighborhood, all of the dishes are pointing in the same direction. It's pointing to the same satellite, essentially. And I'm not sure if you know, if you've been seen where there's a live television news broadcast, and the anchor on the studio is asking a question, and the person who's on the field, you'll notice that there's a few seconds of delay. The delay is because the signal is going to space before it comes back down to whoever's on the ground. Okay, so there is a lag. So we use the fact that the objects can be put into orbit for our own benefit. So there's many thousands of these satellites that are just orbiting the Earth. And at the moment, there's around 10,000 satellites that are operational. But there's close to 40,000 debris or even satellites that are not working at the moment. So this place is getting very crowded, and there's a lot of interventions to see how we can protect this. Because what we don't want is collisions happening in space. And once there's a collision, there's debris that's emitted. And the more debris we have, the more dangerous it becomes. Okay. So I want to talk about some of the uses, how we use satellites for our daily lives. So this is just an example of how we see the world around us in the optical. Okay. So we have the sun that's emitting what we call white light. So if you have been in school and you put a prism, okay, and you shine a white light on a glass prism, and if you look on the other side, you see all parts of the spectrum. Okay, red up to ultraviolet. And essentially what's happening at the leaf structure, you have the primary colors red, green, and blue. But at the leaf structure, the red and the blue is absorbed, and the only light that's shone through is the green. So leaf structures appears green. And that's reflection, some of that actually goes to the satellite itself. And that's what we collect from the satellite. So we build sensors on the satellite that actually gives us a sense of what's coming from the ground, the reflection. Okay. Now remember I told you whatever we see and hear is electromagnetic waves. I'll try to explain this. So we're seeing different wavelengths, different wavelength bands, okay? And by the way, you and I can only see this part. Sorry. We can only see up to here. What's on this side of me, we cannot see. Okay, this is called the visible spectrum. But look at the information that's on the other side compared to what you and I can see. There's a lot more information on the near infrared, the short wave infrared, and so on. And what this is actually showing us is the reflectance at different wavelength for what I've just shown you for plant structure. When you get to the near infrared, those signals that are coming out from that reflection is telling you exactly what structure the plant has. So you can, using this, you can say whether it's wheat, you can say whether it's a maize crop, you can, whether it's just normal grass. So you can differentiate different types of trees just by looking at this structure. Different plant structures have different signatures. And if you go further on this side, this is showing you how much of water is actually in the plant. And we use this for what we call precision farming. So we put satellites into what we call sun-synchronous orbits. So if a satellite comes past at 9 o'clock this morning, tomorrow morning it'll come back at exactly 9 o'clock. So you can stack up the images every day and see how the environment changes. Okay? And if there is any change in any of these spectral signatures, you know something is happening. If the cell structure changes, it might be that there's a disease encroaching. If this part of the signature changes, that means the water content might be down or going up. Okay. So we use that as useful information in terms of how we can do precision farming. And there's very many other use cases that we use for Earth observation or remote sensing based on information that you and I cannot see. So for example, this is a satellite image on your left-hand side. It's showing the red, which is stressed areas. And if you go to the actual field itself, you'll see the plants are actually suffering because of drought conditions, okay? And that's exactly how we use the satellite information. The other use case, I talked about the telecoms, and the satellites are 36,000 kilometers away. And the reason why it's 36,000 kilometers away, by the way, for the low Earth orbits, which is between 400 and 600 kilometers, the satellite comes around every 90 minutes. So it takes 90 minutes for a satellite to go around the Earth and come back. And the same is for the International Space Station. Those astronauts are going around the world every 90 minutes. But the further you go away from the Earth, you go slightly slower. At exactly 36,000 kilometers, you are actually rotating at 24 hours, one cycle every 24 hours. And the Earth rotates in 24 hours. So effectively, that satellite is stationary above one point of the Earth, which is why we call it geostationary. And we use that for putting the telecommunication satellite up, where we bounce signals from those satellites. Okay. The next application, most of you have GPS in your cars to figure out how to get to a specific location. And GPS satellites are essentially satellites that have very accurate clocks, what we call atomic clocks. And they actually are emitting signals that tells you what the timestamps look like. So it can tell you exactly at what time the signal left the satellite and at what time it reached the receiver. And if you have 3 satellites where you're measuring the time it left till the time it arrived, you can calculate exactly where you are on the surface of the Earth, roughly. Okay? And essentially, if you want to measure a point anywhere in this room, for example, you need 3 measurements, X, Y, and Z. And that's why the minimum number of satellites you need is 3, essentially. And you triangulate, and you get a rough estimate of where you are on the surface of the Earth. And this is essentially the rough equation on a 2-dimensional plane, but you can extend that to 3 dimensions. And you can find yourself anywhere on the surface of the Earth. But one of the problems with GPS, I'm not sure if you've observed, if you're driving and you're using GPS, you'll notice that sometimes you're actually on the side of the road, not on the road itself. And that's because there's an error signal on your GPS, which is shown in red. And the error signal can be off by 5 to 10 meters. And that's not good for certain applications, like if you want to land an aircraft in the very rural communities, being 5 or 10 meters out is not good. So you want very accurate location-based services. And the way we do that is we augment the signal. That means we correct the signal. So as opposed to having that spread in red, we can bring that error signal down to within a meter. So with satellite-based augmentation services, we can give you an accurate location to within a meter. So these are the kinds of applications that we are using on a daily basis. And by the way, if you ever went into a bank, into an ATM, and drew out money from a mall, as an example, you went into a mall, the transaction is actually transmitted through a telecommunications satellite, and the time signature for your transaction came from a GPS satellite or a global navigation satellite service. So everything that we do, or most of what we do, is based on satellite services. Okay. Yes, that's the end of my talk. Thank you.
على اللحظة التاريخية اللي نعيشها، مو بس أنا أعيشها، إحنا وأنتم سوية. استمتعنا صراحة بالإطلاق، وأنا متأكد أنكم أنتم استمتعتوا بالمشاهدة. شكرا لكل من دعمنا، شكرا كل من وقف معنا وساعدنا، شكرا لمن وصلنا لهذه المرحلة، شكرا لسمو سيدي خادم الحرمين الشريفين الملك سلمان بن عبد العزيز، شكرا لولي عهده الأمير محمد بن سلمان على هذا الدعم والتمكين والثقة فينا كشباب طموحين برغبة بلهفة بأن نحقق المستحيل بإذن الله مع دعمكم وتوفيقكم. أهلي أنا في الفضاء، الحلم تحقق، اللهم لك الحمد والشكر، وقريبا إن شاء الله في المستقبل القريب الكثير سوف ينضم لنا إن شاء الله، ونراكم قريبا من محطة الفضاء الدولية.
السلام عليكم من الفضاء. والله شرف مرة كبير أن نكون نحن في هذه الرحلة التاريخية. زي ما تشوفونا نطفو يعني ونحاول نثبت نفسنا، لكن فعلا أحب أبدأ الشكر بقيادتنا وصاحب الرؤية ولي عهدنا محمد بن سلمان على دعمه لهذه المهمة. شكرا للهيئة السعودية للفضاء، شكرا أكسيوم، شكرا سبيسكس، شكرا ناسا، وكالات الفضاء اليابانية والأوروبية كلهم على تدريبهم لنا. طبعا شكرا لستي ولعائلتي الجميلة وأصحابي ورواد الفضاء السعوديين علي الغامدي ومريم فردوس على دعمهم في هذه الرحلة. لأبناء الوطن الغالي، نحن الآن في عصر التمكين والازدهار بفضل الله ثم قيادتنا، الحمد لله نحن الآن وصلنا عنان السماء. فكل اللي نحتاج نسويه إنه نحلم بإذن الله ونشتغل على أحلامنا، وبإذن الله رح نوصل.
استقبل رواد الفضاء السعودي موعد الانطلاق والانطلاق رائدين
السعوديين ريانا بورناوي الكورنيك ستسجل تاريخا
بمداد من ذهب
ورفع مستوى الاهتمام بالفضاء لدى الأجيال الناشئة.
Dragon copies. Go for launch.
3, 2, 1. Engines full power.
السعودية أهلا وسهلا، حياكم الله في معارض السعودية نحو الفضاء. معكم أنا أحمد
وأنا طيف. في تاريخ 21 مايو صار في حدث تاريخي للمملكة العربية السعودية، وهو إطلاق أول مهمة علمية للمملكة إلى محطة الفضاء الدولية.
طبعا، واللي كان على متنها أول رائدة فضاء سعودية ريانة برناوي، وعلي القرني أيضا يعد أول رائد فضاء سعودي يصل إلى محطة الفضاء الدولية.
انطلق صاروخ فالكون 9 في هذه المهمة حاملا معه تطلعات المملكة في مجالات الفضاء والعلوم والتقنية.
طبعا ممكن نتساءل كيف أن الصاروخ ينطلق إلى الفضاء؟ اللي قاعد يصير داخل حجرة الاحتراق في الصاروخ هو تفاعل كيميائي بين المادة المشعلة والوقود، واللي بنتعرف على كثير من التفاعلات الكيميائية في تجاربنا الحية لهذا اليوم.
اليوم إن شاء الله بنقدم لكم عرض علمي يحتوي على عدة تجارب ممتعة، ومن هالتجارب راح نتعلم أشياء جديدة، وراح تشاركونا بتجاربنا وتحدياتنا اللي راح نعيشها مع بعض. خلونا نبدأ بأول تجاربنا. مستعدين؟ طيب، قبل ما أبدأ بتجربتي الأولى أحتاج شخصين يساعدوني، إيش رأيكم؟
طيب خلونا نختار
يلا
من هنا
نختار
شخص،
من هنا ومن هنا. ها البنت الأولى هنا، تعالي.
يلا تعالي أنت.
أيوة
تعالي من هنا.
تعالي.
شو اسمك؟ سفانة. طيب نحتاج زميلتنا الثانية. تعالي سفانة هنا.
طيب تعالي معي.
شو اسمك؟ لارا. طيب عطهم تحية. تعالي لارا معي هنا.
طيب أول شيء أنا راح أساعد هنا. يلا بيكم تفتحون علبة المشروب الغازي. يلا افتحيها. أيوة هساعدك. يلا أقوى.
يا سلام عليك.
أيوة برافو عليك. أيوة يا سلام. طيب الحين حنا فتحنا المشروب الغازي، راح أعطي كل من أصدقائي قطعة حلوى، وخلونا نشوف التفاعل وش بيكون معانا. لكن قبل كذا بيكم تعدون معي، ايش رايكم؟ يلا 1. يلا امسكي. 2. لا
يلا من جديد. يلا إذا وصلنا 3 تحطون القطعة هنا. زين
2.
يلا 3. يلا حطوا القطعة. ابعدي شوي.
طيب نعطيهم تحية.
شكرا لك.
طيب مثل ما لاحظتوا معي، أنا لما حطيت قطعة الحلوى على المشروب الغازي صار في فوران سريع. طبعا السبب اللي صار عندي هنا أن القطعة الحلوى اللي معاي تحتوي كمية كبيرة من السكر، هي اللي خلت مشروب الغازي يطلع بهذا الشكل، والذي يحتوي على ثاني أكسيد الكربون. طيب خلينا نسوي نفس التفاعل لكن بشكل أكبر، ايش رايكم؟ ها متحمسين؟ طيب الحين أحتاج ناس أكبر شوي لأنه راح أستخدم مواد كيميائية معي هنا.
طيب أهم شيء كل واحد يكون كرسي، ترى اللي قايم ما احنا مختارينه، أي شخص يكون جالس في الكرسي بنختاره. طيب نختار من هنا شخص، نبغى شخص كبير.
أول شيء أيوة تعال.
مين يطلع معانا؟ اللي لابس أسود. خلاص بس شخص واحد لابس أسود. شو اسمك يا بطلة؟ رفيف. طيب نحتاج زميلنا الثاني. شو اسمك؟
هنا
سعود. طيب عطهم تحية. تعال سعود معي.
طيب أنا راح أستخدم مواد كيميائية، عشان كذا أحتاج أدوات سلامة. يلا أبغى كل واحد منكم يلبس القفازات هنا، وأنا برضو راح ألبس معاهم القفازات. طيب أبيكم تساعدون، إيش ممكن نلبس أدوات سلامة برضو؟ ها ممكن. ها وش اللي قدامنا هنا؟ أيوة راح نلبس برضو النظارات. طيب ها خلونا نستخدم أول مادة معاي هنا، اللي هي مادة ماء الأكسجين. ماء الأكسجين هي عبارة عن مادة، أو نقول ماء مشبع بغاز الأكسجين. هنشوف مع بعض. راح أستخدم تقريبا 200 ملي من ماء الأكسجين. يلا تلبسين النظارة. طيب راح أحط أصدقائي بعد من نفس المادة. يلا الحين أبغاك تاخذ هذا الدورق وتحطه هنا. يلا صديقتنا برضو راح أحط لها كمية من ماء الأكسجين. طيب المادة الثانية يلا حطه هنا. أيوة المادة الثانية ها وشو هذه؟
هذا شيء.
أيوة اللي هو الصابون. راح أحط كمية بسيطة من الصابون هنا عشان أقدر أشوف التفاعل بشكل أكبر. الحين نحط كمية بسيطة. يلا تحط معاي. طيب أبيكم بالمادة الثالثة أنتم تساعدوني هنا. أنا عندي مجموعة من الألوان وأبيكم تختارون معاي إيش اللون اللي ممكن أحطه معاي هنا. إيش رأيكم بالأحمر؟ طيب أخضر، أصفر. طيب راح أحطها. إيش تختار، أصفر ولا أحمر؟ أخضر. يلا ها، وأنت حطي الأحمر. طيب راح أحط كمية بسيطة من اللون هنا. ها يلا تحط معي. أيوة اضغطه. لا من هنا. طيب طيب الحين أبيكم تمزجون معاي الدورق هذا. ها يلا تشوفون في تفاعل هنا. هو بالحقيقة في تفاعل لكن جدا جدا بطيء، عشان كذا أنا أحتاج مادة محفزة لهذا التفاعل وتسرع لي من هذه الكمية. لكن قبل كذا راح أبعد معي المواد هنا. طيب راح أعطي كل من زملائي هنا كمية بسيطة من المادة الأخيرة اللي اسمها يوديد البوتاسيوم اللي راح تسرع لي من هذا التفاعل. لكن قبل كذا أول من نحطه أبيكم ترجعون خطوة للخلف على طول. تمام بس مو بالحين. يلا امسكي هذا عندك. يلا وهذا عندك. يلا مستعدين؟ يلا تعدون معانا. 1 2. طيب نعطيهم تحية. شكرا. طيب لاحظتوا معي هنا صار عندي تفاعل. وش تلاحظون فوق هنا بالخلف؟ أيوة صار في بخار هنا. هذا يدل أن التفاعل صار عندي هنا تحولات أو نوع من أنواع التحولات الطاقة. تحولت عندي الطاقة الكيميائية إلى طاقة حرارية. وبكذا انتهينا من تجربتنا الأولى.
طيب قبل لا نبدأ تجربتنا الثانية خلوني أسألكم سؤال. إذا جينا نروح للفضاء نروح عن طريق إيش؟ الصاروخ. يا سلام عليكم. الصاروخ في نوعين من الوقود اللي هو الوقود الصلب والوقود السائل، ونبي نشوف مع بعض. أنا عندي هنا مادة مشابهة الوقود الصواريخ السائل. نبي نشوف مع بعض إذا وضعناها داخل هذا الدورق وعرضناها للحرارة وش التفاعل اللي بيكون معاي. لكن ترى التفاعل بيكون سريع جدا. خلونا نلاحظ مع بعض. بس كنترول نطفي اللمبات. طيب مستعدين؟ تعدون معي؟ يلا 1. طيب لاحظنا هذا اللهب البسيط اللي خارج من هذا الدورق، وهذا يدل أنه كان عندي كمية من الدفع. خلونا نشوفها بشكل آخر ونضيف نفس الشيء مادة الأسيتون. يلا عدوا معي. يلا 1. طيب مثل ما لاحظنا النار الخارجة من هذا الدورق، لكن خلونا نشوف كمية الدفع اللي تخرجها هذه المادة. لكن أبغى شخص يشارك معي هذه التجربة. مين حاب يطلع؟ ها تطلع أنت؟ أيوة تعال. اللبس أسود. تعال من هنا. يا سلام عليك. متحمس. أسرع واحد جاء من المسرح. وش اسمك؟ لورانزا. طيب عطوه تحية. طيب تعال معي هنا. أبغاك تضيف. امسك. أضيف لي المادة جوا. يا سلام عليك. ها مستعد؟ يلا خلينا نشوف مع بعض وش التفاعل اللي بيصير. طيب أبغاك تجي معي هنا. عندك هذه الولاعة. نولعها على الفتحة اللي موجودة هنا. مستعد؟ طيب أبغاكم تعدون معي. يلا امسك. يلا 1. طيب عطوه تحية. شكرا لك. طيب لاحظنا كمية الدفع اللي تخرجها هذه المادة. طبعا الصاروخ عشان ينطلق للفضاء يحتاج كمية كبيرة جدا عشان يقدر ينطلق من الأرض إلى الفضاء. وبكذا انتهينا من تجربتنا الثانية. تحمسوا تعرفون وش اللي موجود عندي هنا مغطى؟ تحمسوا ولا لا؟ طيب خلونا نشوف مع بعض. عندي هذه التجربة اللي هو مدفع الهواء أو الإير زوكا. هذه التجربة ممكن أي شخص فيكم يقدر يسوي هذه التجربة لأن أدواتها بسيطة جدا. عندي هذا المدفع سوينا له فتحة بسيطة من المنتصف ووضعنا قطعة من القماش في الخلف عشان تساعد على خروج الهواء من هذا المدفع باتجاهكم. لكن خلوني أسألكم سؤال، هل الهواء نشعر فيه ولا نلاحظه؟ ها؟ طبعا الهواء الحين موجود عندنا داخل المسرح لكن ما في أحد منكم يقدر يشوف حركة الهواء. خلونا نشوف مع بعض الحين هل نقدر نلاحظ حركة الهواء أو لا. طبعا أنا عندي هنا قطعة القماش الصغيرة، أبغاكم تقولوا لي هل القطعة هذه تبي تتحرك؟ أيضا هل نقدر نلاحظ الهواء وهو خارج من هذا المدفع أو لا؟ يلا خلونا نشوف مع بعض. طيب لاحظتوا شيء خارج من المدفع؟ طبعا لا، لكننا لاحظنا قطعة القماش هذه تتحرك. لكن خلونا نخلي هذه التجربة بشكل أفضل ونضيف لها كمية بسيطة من الدخان ونبي نشوف مع بعض وش بيكون التفاعل. طيب نضيف كمية بسيطة من الدخان، نبي نشوف مع بعض حلقات الهواء وهي خارجة من هذا المدفع لاتجاه. طيب خلونا نشوف مع بعض. طيب هنا يعني قدرنا أننا نلاحظ حركة الهواء، لكن إذا اختلطت في ذرات معينة أيا كانت ذرات جهاز الدخان اللي موجود معاي هنا أو ممكن في الجو الخارجي اللي هي ذرات التراب، وإذا صار عندنا غبار قدرنا نلاحظ حركة الهواء. طيب خلونا نسوي مع بعض تحدي على نفس هذه التجربة. أبغى 4 أشخاص يطلعون معانا. خلنا نختار من هنا شخصين.
طيب راح نختار من وراء.
طيب من وراء ما اخترنا أحد.
رائد الفضاء اللي هنا واقف معي، يلا تعال. طيب من هنا
اللي لابس أحمر. إيه اللي لابس أحمر. إيه اللي لابس أحمر.
اللي لابسه أزرق هنا شعرك طويل، تعالي.
لا أنا عندي الحين طلع ترى بس واحد لابس أحمر الحين.
رائد الفضاء. واللي شعره هذا اللي لابسه أزرق، اللي لابسه أزرق، بس اللي لابسه أزرق معليش، بس اللي لابسه أزرق هنا.
طيب هذا اللي لابس أحمر. نختار شخص ثاني. طيب نصبر نشوف كم بيطلعون معانا.
معليش مرة ثانية. هذا.
طيب نختار الولد اللي لابس أسود. اللي لابس أسود.
يلا تعالي.
أيوة خلاص 4 أشخاص. تعالوا معي هنا. شو اسمك؟ شو اسمك؟ فراس. شو اسمك يا بطلة؟ ديم. الجوهرة. شو اسمك يا بطل؟ شو اسمك؟ سعد. عطوا تحية سعد، وعطوهم كلهم تحية.
طيب خلونا نشرح التحدي الآن. راح نكون فريقين وراح أعطي كل فريق معه حلقة، تمام؟ بنشوف كل واحد راح نعطيه مدفع صغير من مدفع الدخان هنا، وبنشوف كم فريق يدخل لي حلقات دخانية جوا هذه الحلقة. مستعدين؟ طيب يلا تمسكي ولا تعالي هنا، خليك أنتي مع المدفع. يلا تعالوا هنا، يلا.
طيب مين تتوقعون يفوز؟ عندنا الفريق الأول. يفوز ولا ما يفوز؟ طيب ولا الفريق الثاني؟ يعني كلهم قريبين من بعض. خلونا نشوف مع بعض. مستعدة؟ طيب خلينا نملأ اللي هو هذا المدفع بالدخان. طيب وقت تمسكين بيدك هنا تحت. يا سلام عليك. تسحبين القطعة اللي موجودة هنا. يلا لك 3 محاولات. تسحب القطعة. فكي. يلا 1. يلا بقيك محاولتين. 2. يا سلام عليك.
برافو.
3. عطوه تحية.
دخلتهم كلهم.
طيب خلونا نشوف الفريق الثاني. مستعد؟ طيب تروح هناك. مستعدة تجيبين كلها 3 محاولات؟ يلا خلونا نشوف مع بعض. طيب مسكين المدفع من هنا. يدك. أيوة. يلا فك القطعة. 1. يا سلام عليك. باقي لك محاولتين. 2. يلا يا سلام عليك. 3 محاولات. أعطوهم تحية. شكرا لكم، يعطيكم العافية. طيب
شكرا.
يعني لاحظنا من هذه التجربة أننا نقدر نلاحظ حركة الهواء، لكن إذا اختلطت فيها ذرات معينة أيا كانت ذرات جهاز الدخان اللي موجود معاي هنا اليوم أو ممكن في الجو الخارجي اللي هي ذرات التراب، وإذا صار معنا الغبار قدرنا نلاحظ حركة الهواء. بكذا انتهينا من تجربتنا الثالثة.
أدوات ومواد مرة كثيرة نقدر نسوي منها تجارب، مثل اللي مثلا نستخدمها بالطبخ أو بالزراعة أو حتى بالتنظيف. اليوم أنا معي نشا الذرة، تتوقعون آمن ولا خطير؟ آمن بالفعل، هو بالأصل آمن، لكن خلونا نشوف لو عرضنا نشا الذرة الحرارة إيش ممكن يصير معانا. طيب أنا عندي أنبوب هنا حطيت فيه كمية بسيطة من نشا الذرة وراح نعرضه للحرارة الآن. يلا تعدوا معانا. طيب خلونا نجربها مرة ثانية.
طيب يلا ها تعدون معي. يلا 1 2.
طيب لاحظتوا هنا أصل نشا الذرة هو آمن، لكن لما عرضناه الحرارة قدرنا إن نشغله. طبعا هنا في أكيد سبب. السبب إن لما نفخنا النشا وتوزع على السطح بشكل أكبر تداخلت فيه ذرات الأكسجين بشكل أكبر، عشان كذا حنا قدرنا نشغل النشا. وبكذا انتهينا من تجربتنا الثالثة. طيب خلونا نتعرف شوي على الضغط الجوي. لما أحد منكم كد سافر بالطيارة مثلا أو راح الأماكن مرتفعة، تلاحظون باختلاف أذانكم ولا لا؟ طيب الاختلاف اللي بالإذن هنا يصير هو بسبب اختلاف الضغط الجوي اللي راح نشوفه بتجربتنا هنا بشكل أكبر. طيب أنا معي هنا وعاء فيه موية باردة جدا حطينا فيها الثلج وراح نحط فيه البرميل. البرميل هذا جواته ماء وغليناه لدرجة حرارة جدا عالية. بنشوف مع بعض إيش ممكن يصير لو عرضنا هذا الشيء. يعني مثلا عندنا الوعاء اللي تحت بارد جدا والبرميل اللي معي جدا ساخن، راح أيضا أبرد البرميل هنا بس. طيب أبيكم تلاحظون معي وش تتوقعون ممكن يصير هنا. انفجار. طيب وش تلاحظون فوق البرميل هنا؟ بخار بالضبط. طيب خلونا نشوف هنا قاعدين نبرد البرميل أكثر. طيب خلوني أوضح لكم إيش ممكن جوا البرميل، إيش العملية اللي تكون فيه جوا. العملية هنا في بخار موية قاعدة تتحول إلى سائل مرة أخرى، وهذه العملية هي عملية تكثف جوا البرميل. وخلونا نشوف إيش ممكن يصير من اختلاف الضغط معاي هنا. طيب ممكن تطول معانا، خليكم مستعدين.
ها تتوقعون ينفجر ولا يصير شيء ثاني؟ خلونا نشوف مع بعض. انتبهوا أجل الذي بينفجر.
طيب ممكن تطول معانا العملية. ها مستعدين؟ طيب ايش لاحظتوا معاي هنا؟ ايش صار؟ طيب هو صار عكس الانفجار تماما، صار عندي انكماش. خلونا نوضح أكثر اختلاف الضغط هنا. لما صارت العملية اللي شرحتها اللي هي عملية التكثف جوا البرميل، صار جوا البرميل الضغط خفيف وضعيف جدا، بينما الضغط الخارجي للبرميل جدا عالي، بالتالي ايش صار فيه؟ انكماش وليس انفجار. طيب وبكذا انتهينا من تجربتنا الرابعة.
تجربتنا الأخيرة بنتعرف فيها على تحولات الطاقة، واللي بتتحول عندي الطاقة الكيميائية اللي موجودة عندي داخل البالونتين اللي موجودة عندي هنا إلى طاقة حرارية وضوئية وقليل من الطاقة الصوتية. طبعا هذا الشيء اللي هو تحولات الطاقة من شكل لآخر اللي هو القانون الأول للديناميكا الحرارية. لكن أبغى شخصين كبار يشاركون معنا هذه التجربة. كبار خلونا نشوف مين حابب يطلع. ترى اللي يقوم من كرسي وأنا ماني مختاره، لكن مرة ثانية ودي أقول أبغى أشخاص كبار. نبي أشخاص كبار يا جماعة.
اللي هنا
يطلع
اللي لابس تيشيرت هنا
أبيك أنت تطلع.
أنت تعال يلا.
طيب مين بنختار شخص ثاني؟ مين؟
اخترنا هنا في واحد طلع.
أي واحد، أبغى شخص ثاني. انت اطلع اللي لابس اسود، اللي لابس اسود. ايه لا اللي لابس اسود اطلع. ايه اذا ما ودك نختار واحد ثاني. يلا تعال. طيب ما تعرفنا وش اسمك؟ فيصل. طيب نحتري زميلنا الثاني. عرفنا باسمك. خالد. طيب اعطوهم تحية. طيب انا عندي هنا هذه البالونتين، لكن فيصل ابغاك تجي عندي هنا شوي. يا سلام عليك، عند البالونه اللي موجوده هنا. طيب وخالد ابغاك عند البالونه الحمراء. لكن خلونا نشوف مع بعض. انا هذه البالونه موجود فيها نوعين من الغاز، اللي هو غاز الاكسجين وغاز الهيدروجين، والبالونه اللي موجوده معاي هنا فيها غاز واحد. نبي نشوف مع بعض اذا عرضناهم للحراره وش التفاعل اللي بيصير معانا. لكن ابغى انبه على شيء بسيط، انه ممكن الصوت يكون مرتفع، فنسكر اذاننا اذا جينا نسوي هذه التجربه. ها مستعدين؟ طيب نبدا بالبالونه اللي موجوده هناك.
طيب
مستعد فيصل؟
طيب قبل ما نبدا نحتاج ادوات سلامه.
طيب
فراح نحط الفيصل السماعات. يلا البسها. يلا مستعدين؟ يلا نعد مع فيصل. يلا يلا امسك العصا. يلا
طيب خلونا نشوف مع بعض البالونة الثانية اللي فيها نوعين من الغاز. بس خالد تقول أنت انهبلت من قبل لا تبدأ تجربتك، أبغاك تمسك العصا من آخر شيء، وأبغاكم تعدون معاه. ها تعدون؟ يلا لا نصبر شوي لأن الهواء قوي. طيب أبغاك تمد يدك كامل. يلا 1 2 3. قرب. طيب أعطوهم تحية. يعطيكم العافية. طيب خلوني أبغاكم قولوا لي أنتم وش الفرق بين البالونة الأولى والبالونة الثانية. الثانية وش فيها؟ يا سلام عليكم، البالونة الثانية صوتها كان أعلى، وهذا بسبب إن فيها نوعين من الغاز. طبعا في شيء اسمه مثلث الحريق. مثلث الحريق هذا يحتوي على 3 عناصر. العنصر الأول اللي هو المادة القابلة للاشتعال، واللي موجود معاي اللي هو غاز الهيدروجين. العنصر الثاني اللي هو الطاقة الحرارية اللي خارجة من الولاعة. يبقى لنا العنصر الثالث واللي هو مهم جدا في عملية الاحتراق، ولا يمكن يكون عندي احتراق إلا بوجود هذا العنصر اللي هو غاز الأكسجين. فاكتملت معانا 3 عناصر في البالونة الثانية، عشان كذا كان صوتها أعلى من البالونة الأولى. وبكذا انتهينا من تجاربنا لهذا اليوم.
لكن حابين ننبه على شيء جدا مهم، انه هذه التجارب جميعها خطيرة، فممنوع ان نسويها بالبيت ابدا.
شكرا لحضوركم.
مع السلامة.
An awesome experience.
السلام عليكم ورحمة الله وبركاته. اللهم لك الحمد الشكر، الحمد لله على الفرصة، الحمد لله على اللحظة التاريخية اللي نعيشها. مو بس أنا أعيشها، إحنا وأنتو سوية. استمتعنا صراحة بالإطلاق، وأنا متأكد أنكم أنتو استمتعتوا بالمشاهدة. شكرا لكل من دعمنا، شكرا كل من وقف معنا وساعدنا، شكرا لمن وصلنا لهذه المرحلة، شكرا لسمو سيدي خادم الحرمين الشريفين الملك سلمان بن عبد العزيز، شكرا لولي عهده الأمير محمد بن سلمان على هذا الدعم والتمكين والثقة فينا كشباب طموحين برغبة بلهفة بأن نحقق المستحيل بإذن الله مع دعمكم وتوفيقكم. أهلي أنا في الفضاء، الحلم تحقق، اللهم لك الحمد الشكر. وقريبا إن شاء الله في المستقبل القريب الكثير سوف ينضم لنا إن شاء الله، ونراكم قريبا من محطة الفضاء الدولية.
السلام عليكم من الفضاء. والله شرف مرة كبير أن نكون نحن في هذه الرحلة التاريخية. زي ما تشوفونا نطفو يعني ونحاول نثبت نفسنا، لكن فعلا أحب أبدأ الشكر بقيادتنا وصاحب الرؤية ولي عهدنا محمد بن سلمان على دعمه لهذه المهمة. شكرا للهيئة السعودية للفضاء، شكرا أكسيوم، شكرا سبيس اكس، شكرا ناسا، وكالات الفضاء اليابانية والأوروبية كلهم على تدريبهم لنا. طبعا شكرا لستي ولعائلتي الجميلة وأصحابي ورواد الفضاء السعوديين علي الغامدي ومريم فردوس على دعمهم في هذه الرحلة. لأبناء الوطن الغالي، نحن الآن في عصر التمكين والازدهار بفضل الله ثم قيادتنا الحمد لله. نحن الآن وصلنا عنان السماء، فكل اللي نحتاج نسويه إنه نحلم بإذن الله ونشتغل على أحلامنا وبإذن الله رح نوصل.
استقبل رواد الفضاء السعودي
موعد الانطلاق
والعشرين
رائدي